can use and access services like server, be it server or storage or database or networking, etc., with the use of cloud computers. And the futures of cloud computing would be on-demand self-service. As I said, you can take any service like server, storage, database, networking, analytics, etc. Depending upon your demand. You do not need to take a huge amount at once or a low amount at once. Next, broad network access. It can be available from anywhere throughout the standard mechanisms with the help of internet. Resource pooling. You can pool the resource with multiple customers. A single resource can be shared among multiple users. Rapid elasticity. You can scale or down it rapidly according to your use. Measured service. Resource usage can be monitored and controlled. Can we go to the next slide? So this cloud computing has three major service models, which we called as IaaS, PaaS, and SaaS. IaaS is infrastructure as service, provides virtualized computing resources over the internet. Example would be AWS EC2, Google Computing Engine. And for platform as a service, it provides a platform to develop, build, or test the applications. Now, examples would be Google App Engine, Microsoft Azure App Services. For software as a service, we deliver the software applications using the help of internet. One example, this is the most used cloud by normal users. That is Gmail, Microsoft 365, Zoom, Salesforce, etc. Now, what is the evolution of hypervisor in cloud computing? So, as we discussed early days, hypervisor like VMware is introduced on the management of physical servers. But for cloud era, it became backbone for cloud infrastructure. Depending upon basing the hypervisor, the cloud computing services has been developed a lot. It acts as a backbone for it. We know it is EC2, which used, etc., etc. Serverless support. It evolved with the support of new paradigms like serverless computing and microservices. And containerization integration. So now hypervisors are coexistent with containers for lightweight virtualization. This is the evolution of hypervisor in cloud computing. Next, high performance computing workloads in cloud environment. It is molecular dynamic. Now, let us see the usages of high performance computing in cloud computing environments. For molecular dynamics, that is, for drug discovery, we can use this. Next, for weather forecasting, it can be used. For fluid dynamics, such as aerospace and automotive design. For genomics, DNA and DNA sequencing and alignment. And financial risks, that is Monte Carlo simulations. Next slide. Now let us see what is sky computing. Sky computing is an advanced framework that envisions multiple integration of distinct cloud providers into one seamless interoperable cloud of clouds. So now what does this mean is, let us imagine a cloud. This single cloud service has an usage as we discussed before. Now a user cannot use multiple clouds at once, but with sky computing, it is possible. All these three clouds can be used at once. This is sky computing. So, what is the advantages or main goal of introducing sky computing is interoperability. That is, the data can be moved freely from one cloud to the other. Next, global reach and resilience. So it collects infrastructure of multiple providers for enhanced fault tolerance and geographic distribution. Next, optimized resource utilization. It is optimized than cloud systems. From here on, Giridhar will take over and complete the rest about sky computing. Thank you.
Yeah, I'm here to discuss about first implementation and origin of sky computing. As my friend discussed about sky computing, it is cloud of clouds. So basically, it was first the idea of sky computing was emerged in 2009 and 10, where all researchers have found it, like University of California. They thought about multiple cloud interoperability, which is like how to implement those multiple clouds in one. Because if we use Microsoft Azure, we can't shift directly to Google. It is very tough because there is a problem called vendor lock-in in cloud computing. So early objective was cloud of clouds, as we discussed, that abstract away differences between providers and enabling seamless workload migration. So first implementation was prototyping the Federation Cloud Services. They took AWS, Microsoft Azure, and also Google Cloud using orchestration tools and APIs. By this, they started the first implementation of sky computing. The key technologies used were hypervisors for virtualization inside each cloud, federation identity management for cross-cloud authentication, and also OpenStack and Kubernetes as orchestration layers. The, the pilot projects are early experimental deployments occurred in academic HPC centers and distributed research networks, where cloud computing needs exceeded the capacity of any single provider. The evolution of sky computing over years. We saw like in 2010, they first, as we before discussed, they started that cloud in clouds idea. So after that, prototype and industry exploration and standardized efforts and practical deployment was done on 2021, which is tech giants like AWS, Google, Azure has did the cross cloud orchestration tools. And present trend of sky computing was still evolving. Like most providers are in early adoption or proof of concept stages. Partial interoperability, which is some efforts like Kubernetes Federation, Anthos, and AWS Outposts. And standardized lacking. No unified APIs or orchestration standards yet. Okay. Now it is going like it is growing demand, like especially from industries needed cross coding, because as they are using different technologies, like if they are using like they need cloud services like kind of Microsoft Azure, and also they need some services from Google, but they couldn't manage in those cloud bases. And real world use cases. These are some real world use cases we used in Netflix, CERN, and use a hybrid cloud approach involving multiple providers for data instance. And this integration mechanic works by using hypervisors within each cloud data centers to virtualize resources and enable multiple tenancy, like multiple like hypervisors were in the virtualization standard. So for this, the foundation was hypervisors within each individual cloud. Hypervisors remain the fundamental layer. Okay. And orchestration tools. Cloud platforms employ sophisticated orchestration tools and sky computing abstraction layer. This critical layer sits above individual cloud orchestration. Need for integration. As we all now discussed about the need of integration, like it avoids vendor lock-in, maximum flexibility, cloud optimization, enhanced scalability, and high availability. The major benefits on unified infrastructure were resource efficiency, dynamic scalability, accelerated eligibility, and significant cost savings. Improved reliance and enhanced security also give the best advantage for the sky computing.